Greetings folks and welcome to the Electromaker podcast. This is a roundup of all things Maker and Embedded and Lovely, including news from the Embedded and Maker world, but also new products and a bunch of fantastic projects, because the Electromaker community is, in the largest sense, a project community. We do have a Discord server, our website also has a shop, and if you buy things from that, it would make me very happy because it financially supports this podcast. But at the heart of things, we are a community of makers, and this show is chock full of amazing maker projects. There is a video version of the show you can find on YouTube, which has all of the visual stimuli you would need in order to make sense of things that don't make sense in an audio format. That said, I have been frequently told that I talk enough to make it obvious what is happening on screen, even when you cannot see that screen. We'll also be very briefly talking about the potential IPO for Raspberry Pi, although essentially I say in this episode, just listen to what Jeff Geerling says about it, because my views mirror his quite heavily. And we'll be looking at our product of the week, which is the Zimablade, as well as announcing the winners of our Electromaker of the Month contest for January, where we give cash prizes to members of our maker community. With that and several other things to get through, let's start the podcast for this week. We're going to start this week's show by looking at a smart patient monitoring system uploaded to the Electromaker project hub by Aaron Varghese. This project combines a huge amount of different elements, including the actual sensors that attach to the patient, including ECG monitoring, blood oxygen level monitoring, and inside the same finger sleeve as the blood oxygen monitor sensor is a Xiao NRF 82540 sense board. And the sense is very important because that can also sense movements. And that data is being sent through a model that has been trained by Edge Impulse in order to inference different kinds of data out of it, including the way a patient is moving, for example. Now, all of this data is part of a much larger system, and the brains of the operation is an STM32-based Nucleo development board, and that is sending that data to the cloud via a Blues note card. This is a fully cellular system. It does not require on there being local Wi-Fi, for example, or any kind of wired connection. And once it is in the cloud, the endpoints there are the Car IoT platform, which is a cloud IoT platform which provides most of the things you'd expect from an IoT platform. You can visualize the data, as we will see in a moment, and you can attach various endpoints to various things. But some data is also sent to Twilio, which is a call and messaging service that you can use online. I'm sure many of you are already familiar with it. The idea here being when certain things are detected, a doctor can be told straight away via text message, rather than having to go through other means. And depending on the situation and the geography of the situation, it might be a very important thing. A fantastic sentence in the situation and the geography of the situation. Perhaps a better sentence would be, not all medical situations are made equally. This uses very cheap tools and cellular IoT along with text messages, making it deployable pretty much anywhere where those things are actually covered, which covers a lot more of the earth than the usual wired and Wi-Fi lifestyles that we are very used to. Now, at the sensor end of things, there are two DF robot parts. A blood oxygen sensor, which sits on the finger, which goes inside the finger sleeve that I showed in the initial image right here. And there's also a heart rate monitor as well. And I'd like to point out, well, firstly, if you want to support us, we sell these parts. You can buy them from us, and that would, of course, help the show massively. What I did not realize until I looked this up is that this comes as an entire kit. The pads and all the things that you're seeing here are all part of the Gravity Heart Rate Monitor kit, which is $20. And that includes the board, which works via Stemma QT or I2C, whichever way around you want to do it. You can wire it into pretty much anything. And it comes with all of the pads and all this kind of stuff, which I didn't realize. I thought that was quite cool. I'll say it once now, and I won't bother saying it for the rest of the time I'm talking about this project. Pretty much everything that's a part of this project is available from us if you would like to replicate it. Even if not, the NRF 52840 Sense is pretty much my favorite Xiao board. It's cheap. It has an amazing Bluetooth Low Energy chip in it from Nordic. It has a bunch of sensors on board. I really like it. The blood oxygen monitor is also available from us too. Now, the use of the Seed Xiao NRF 52840 Sense board is one of the things I find very interesting in this project. So I've jumped ahead a little bit in the project so you can see how it was all put together. Now, we'll talk about the Blues note card setup and the STM32 in a little bit when we talk about the software setup and the cloud setup. But this little finger sleeve is what I was talking about just before. It houses the NRF 52840 Sense, it houses the blood oxygen monitor, and for now there's just a short cord attaching it to the main body here for testing. But on board on the NRF 52840 5840, it's performing inference over a model trained with edge impulse. And the model is trained on movements. So if you have this thing on your finger, yes, of course, it's picking up your blood oxygen level and sending it into the main board for processing to do whatever you want with it. But every time this movement is happening, a model is saying, what kind of a movement is it? If someone's just raising their hand, they might be trying to get attention. But if a hand is moving specifically back and forward a lot, in a very short period of time, it might mean something more medically significant, like someone is having a seizure, or someone is just upset. When someone is physically upset in a medical environment, it's usually a good reason to go and check what's going on with them, because it means something has probably changed. And this is all happening on board, on the NRF52840 board. All it is doing is firing out that data over serial. And so basically, it's saying over serial the patient is not moving or the patient is moving in a certain way. All of that processing power is on board in a tiny little low power board on the finger. I thought that was a really nice touch, a really nice idea. Given that the blood oxygen level and the ECG also have their own microcontrollers on board anyway, why not use a little development board as part of it there, instead of having to do all of it on the STM32? Now, I'm going to move straight on because there's still quite a bit to get through and I don't want to spend too much time on one thing. But needless to say, read this project. There's a link in the description. The next part goes through how they used edge impulse to train a model. This is showing up in a lot of hobby projects. It's easier than you would think to do. I'm going to do a feature on it at some point. But yes, in short, they gathered data, sent it to edge impulse. Edge impulse sent them a model back, and now they have a tiny ML device as part of their project. But here's the next part of this that makes it quite an interesting thing. You could use the STM32 just as a powerful microcontroller and do all of your processing in a super loop. That's the idea that many people who come from Arduino are very used to. You set up at the very start, and then you loop around the same code over and over again, and it takes as long as it does to get to the bottom of the loop, and then it starts again. An alternative to that is the concept of using a real-time operating system. Real-time operating systems can seem incredibly complicated. I still struggle with it somewhat, despite the fact that I've been putting some real time into trying to learn real-time operating systems. That's another classic sentence, Ian. But this is a very good diagram for showing exactly what's happening. A real-time operating system will break up tasks into parts based on priority, and it will make sure that certain things always run at certain times, giving you timing guarantees. If you need a bit of sensor data every X milliseconds, a real-time operating system will guarantee that you are able to get that kind of sensor data, provided there isn't an error with that particular sensor, regardless of what's going on in the rest of your system. So in time-critical systems like medicine, they're very, very desirable for developers and, of course, for end users as well. You don't want your super loop hanging on something unimportant when you need to know the patient's vital signs. So, back to this image of the finished box. This is the heart rate monitor, which breaks out to those pads I showed you before. This is the thing going to the finger pad, and the STM32 development board. Now, the real-time operating system running on that board is just running all of these tasks in a line. They have different priorities. That includes the sensor data from the Xiao, the sensor data from the ECG monitor, and the sensor data from the pulse oximeter. And all of this data is also being sent to the cloud via a Blues note card. Now, we talked about the note card on many occasions on this show. It's one of the easiest ways you can get started with cellular IoT. It uses JSON commands back and forth, and the Note Hub as well is a great way of logging data in its own right, but it also allows you to forward directly onto other services as well, which is what happens here. So let's jump into the cloud side of it. So we have a bunch of patient data, and you need a way of storing that and visualizing it. In this particular instance, they're using Car IoT, which is a cloud platform for IoT, not one I've used before or had even heard of before this project, but it appears to be very similar to various other ones. It gives you a bunch of options for adding different devices, and it gives you this idea of an endpoint, and you can do with the data what you will. It seems to work similarly to most of the ones that I've used before, and have some fairly nice device visualizations and dashboards. So for example, you have the dashboard here, nice big letters, nice big graph. You could imagine this being up on a screen, maybe on the door of a patient's room or something like that, so you can walk by at a glance and see all of that data. But of course, that's not the full story here. They also have Twilio for sending alerts. And Twilio, as I mentioned before, is a call and SMS service that allows you to send alerts, via mobile phones about certain things. And in this particular instance, there's certain kinds of data that you would want to know about and send to a doctor immediately. Certain variances in heart rate, for example. Certain variants in movement. As mentioned before, the Xiao is designed to move to determine certain movements. And there are some things that if you think your patient is having a seizure, you want a doctor to know immediately. And being able to send them a text message, again, depending on the situation, might be the fastest way of doing it. I'm sure in modern hospitals in the Western world, world. There are going to be other ways of doing this, but the idea of this proof of concept is that this could be deployed absolutely everywhere. And yeah, and that's exactly what it does. Now, if you'd like to find out more about this, I haven't been able to give this the time it deserves, despite spending a little longer on it than I wanted to, because it is such an in-depth project. It is amazing that one person has come up with this just sort of as an idea. They said, oh, well, surely you could do patient monitoring and make it better in this way and that way. And the proof of concept, while obviously not kind of medical grade, shows that if one person can do this in their spare time with some fairly cheap parts, a fairly small amount of investiture and ideas could go together to make this something that was deployable. It doesn't have to be something that millions and billions is poured into before it becomes viable. That's one of the things I really like about this. I would not be surprised if I am not briefly talking about this again in a little while when we talk about Electromakers of the Month later on for the next month. I have a feeling our judges are going to love this as well. Speaking of which, our Electromaker of the Month winners for January, we're going to talk about them this episode just a little bit later on. But if you'd like to know more about this particular project, you can find a link to it in the description of this video. Now, we couldn't put out a show this week without talking about the possible IPO that's happening with Raspberry Pi. They're thinking of floating the company on the UK stock market. And of course, this means that the people in charge of Raspberry Pi will no longer really be in charge. Once you have shareholders, the shareholders pretty much run the show. And I was sort of wondering what my thoughts about this would be before, watching Jeff Geeling's video and realizing that he said pretty much everything that I would have said, but said it in a far shorter way. I mean, far be it from me to talk at length about things when I don't need to. It's not how I made my entire career happen or anything. No, Jeff gives a very balanced view on both sides of it. Basically, his reasons why he thinks it might be a bad idea very much match my own, and they can be summed up in that sentence I said before. Once shareholders are the ones in control of the company's not really thinking about what we, the consumer, want anymore. However, he also busts a few misconceptions, and if you had heard about this news and wanted just a quick place to look as to kind of the ins and outs of it and what it might be and what it definitely is not, Jeff's video is fantastic. But I mean, of course it is, because Jeff is pretty much the YouTube Raspberry Pi person. I think I actually referred to him as the Raspberry Pi daddy in a social media video a little while ago, and I'm hideously embarrassed about that. By the way, fun little moment for me, I thought I was very clever when I saw the title of this video in my feed and it said Raspberry Pi IPO, are they selling out? Question mark. And there's this thing called Betteridge's Law, which states that any headline that ends with a question mark could be answered with no, and I felt very clever, and then I looked at the very top of Jeff's video description, Betteridge's Law strikes again. It is time to look at the winning Electromaker of the Month entries for January. Now, everyone who uploads a project to our project hub, which you can do for free with an Electromaker account, it only takes a couple of minutes to make one, they automatically get entered into the Electromaker of the Month contest. We have a panel of independent judges who take the time to go through every project each month and choose 3 winners. And they win a big pile of Electromaker swag and an Electromaker certificate. But also, thanks to our generous sponsor, Koitech, cash prizes. The winner wins $150, second wins $100, third wins $50, and on top of the Electromaker swag, you win a pile of Koitech branded swag as well. And so a big thank you to Koitech. If you're not familiar with them, they make hardware and software tools which allow you to look into the power your project uses in just an amazing level of detail. You can emulate batteries using their hardware. You can automate processes to check every single power eventuality for your product. If you're using energy harvesting in your project, this could be the difference between it working or not, or being better than someone else's product or not. Have a look at Koitech.com if you'd like to find out more. And thank you so much, Koitech, for generously sponsoring our Electromaker of the Month and allowing us to give away cash prizes every single month. I've said the word month quite a lot. Let's just look at the projects. I will link this blog in the description of the video. This just summarizes the 3 winning projects. But we're going to start with first place, which wins $150 and a pile of swag. This is the green box from Electromaker user Daniel Legut. Now, I probably mispronounced your name, Daniel. Apologies for that. But this is a cellular IoT power monitor, which also uses that cellular IoT in order to trigger the on or off state of the box. So there's a relay in there, there's a current sensor in there, and there is cellular IoT provided by a Blues note card. They're showing up in pretty much every project I look at that uses cellular IoT at this stage. They must be doing something right. But the first thing that I want to mention is just how professional this box looks. This is a homemade enclosure, but it doesn't look like it. It looks like something that you might actually find in an industrial environment or maybe even in a consumer environment. Even what looks like the Molex branding on the box is just the aerial from the note card, or the note carrier in this case, which is the baseboard that the cellular IoT module from Blues fits on. And I know that sounds like such a little thing to stick on, but as someone who has made dreadful looking boxes for every project I've ever made, it's so nice to see someone who really cares. And as they mention in the project, having a good enclosure that you can iterate over makes it much easier to work with things. Things aren't flying around and moving around all the time. And a big part of the documentation of this project is how they made such a nice looking enclosure. So this image here is a great way to see what's going on here. Now, ignore the fact that the relay looks like it has been photoshopped in. Daniel, I feel your pain. I've submitted paid things in the past that needed photoshopping in order to make sense. This is something that just happens when you document projects. But to visualize every aspect of this project, so I don't end up talking about it for too long, let's just say you have the power from the wall coming in down here. That power will then split, and part of it goes through the current sensor here and into this relay. Now, if this was a normally closed relay or normally open, depending on the terminology, I always get that mixed up. But the point is, if this relay let current through as standard, then this thing would work just as it is. It will work as a power box. There's a big chunky switch on the box, as you saw. You could use it just as an on-off switch from the wall. However, the split power here goes into this power supply here, which steps it down from the 1, however American is, or 240 volts, down to the 5 volts that the note carrier can use. And so it goes into the note carrier here. These are not connected. And the note carrier is what is controlling the relay just here, probably not with that pin. And it is also sensing the current here, probably not with that pin either. And this is the beauty of the entire system. Whatever power is coming in and through the current sensor and through the relay, that's the only power that the system is measuring. It's not measuring how much power it itself is using, which is very useful if whatever your project is needs to have some quite accurate measurements. Although in this case, it looks like either a television or a microwave. I'm not really sure what that's meant to be. Anyway, the other side of it that's nice is that all of that data gets sent up to the cloud. You can do what you want to it. It can go into the Note Hub. It can be sent onto another IoT platform, as we saw earlier in this episode, and visualized. But by using the Note Hub API, you can also send API requests to turn this relay on or off, which means that it becomes essentially a cellular IoT smart home device. You can turn that on or off from anywhere in the world by using a server request. You could make that server request part of a phone app or whatever. In this particular instance, they just use the Python code as a kind of proof of concept way of doing things. But yes, this is a project that really impressed me at the time when I saw it. It clearly impressed our judges too, and this is why Daniel has won a $150 first prize for January. In second place and winning $100 is RescueBot. Now, this is a incredible project, the scope of which is massive. It's by Latency Zero, who are a team of people from a university. And it's one of the, from my own perspective, one of the more impressive projects I have seen. This is a fully functional rescue rover incorporating Edge AI into a custom chassis, which, as I said, is a proof of concept, but it proves the concept that you can use relatively cheap parts to do a huge amount. So much, in fact, I'm going to have to really whip through this very quickly to tell you every element of it. Now, I'm going to only touch on a few aspects of this because I just don't have time to go through all of it. But there's a bunch of sensors on this robot which are chosen specifically for the use case. As I said, this has much wider implications as a rescue rover in general, but they're thinking of the health of mine workers, which is one of the reasons why there's a gas sensor on this rover. And if I go down to an image of it, by the way, the documentation here is just incredible. Not only how they did it, but the reasons they chose different things and issues they had and how they got over them, even down to the data sheet of the motor and why they chose it and the torque it had, all that kind of stuff. But yeah, let's have a quick look in the body here. This is the NVIDIA Jetson Nano that is the brains of the operation. That's a slightly nicer view of it. This is what is doing all of the computer vision on board. There's a depth-based camera that you're going to see on the finished rover in a moment, along with a LiDAR sensor. So the LiDAR sensor, much like the ones you'd find on a modern automatic vacuum cleaner for your home, can make a 3D map of an area. And it can do that completely independently. And the depth camera can sense depth, of course, but it can also do things like pose estimation, which is an important aspect, because if you are sending a robot into an area, the gas sensor will be able to tell if there are any noxious gases in the air, but the pose of the people in that area, especially in something like a mine, is probably going to give you important information as to whether those people are doing well. If they are lying on the floor, for example, that's probably not a good thing. Neither is it if they're waving their arms around. That might mean that they're trying to get attention to try to get help or something like that. And as I mentioned, there's things like they realized that their original chassis design wasn't strong enough, so they designed some new ways of making it stronger just on the fly. And this is included in the documentation. Very useful stuff for people that might be doing this for the first time themselves and wondering how that they can fix issues as they come to them. I wish more people would put their mistakes in their documentation. But yes, as previously mentioned, there is a LiDAR camera on the top of here, and they go through exactly how they got it going. And there's a good example here of them setting up the mapping. So they have the laptop just here, and they have the rover going around the, I believe, the basketball court of their campus. And the little LiDAR, you can see the little LiDAR sensor on top of it spinning around here, doing its job. And again, this is a nice view of the 3D camera as well. You can see the 3D camera up on top of there, as well as the LiDAR sensor. And just below here is the map they made of their basketball court. And I don't have time to speak about this anymore. I could speak about this for a lot longer. At some point in the future, maybe I will have to do a specific show about things like rovers that are using Edge AI, because there's a lot of wonderful projects like this. And I know a small amount from a very high level, like most things I talk about how you would go about making something like this yourself. If you're interested in a whole sort of Edge AI vehicle episode of the Electromaker Show, I'd be more than happy to make one based on my limited knowledge, and maybe we could learn a little bit about it together. But yes, the robot itself, as I say, was designed specifically to work through various terrains, and they have tested it on various terrains. And I didn't even get into, I know I mentioned it, but I didn't even get into things like the edge, the depth perception of the camera, pose estimation. Yeah, exactly. Like, you know, what people are doing with their hands, all of this kind of stuff. And just to remind you that this is a project by a group of students who are putting this thing together as part of their course, and just look at it. It is definitely something that I think of as one of the more beautiful and together projects of its type that I have seen. And I really look forward to seeing where it goes. Guys, if you see this, congratulations on a wonderful build. And in third place, winning $50, and of course the pile of Electromaker and Koitek swag I mentioned before, is this Arduino flower-shaped project. And when I saw this on the Project Hub, I really hoped it would be recognized by our judges, because this is exactly what I talk about when I say that innovation and the idea of doing something new, even if it is relatively simple, is something that should be celebrated. And I love this project so much. This takes one of the lily pad-shaped Arduinos and places it into something that looks like a flower, breaks out all of the pins into LEDs, and then puts a little microphone module down here which can pick up sound, so it can be sound reactive, or it can just flash up in a few different ways. So I have the sound off, but what you're seeing is this thing reacting to the sound on the phone, which is playing into the little microphone module just there. And just the aesthetics of this project pleased me so much, and I'm very glad that our judges recognize that as well, because it is a very sort of mechanical and futuristic looking statue, but it is also something that you could put in the corner of your room, and at first glance someone might actually think, oh yeah, that's just a plant, and then they'll go, wait, well no, that's a circuit board. What is that? It's just a very interesting thing, and it's a nice use of what is essentially a good beginner project, because breaking out LEDs from a board is maybe the first circuit some people will make. Yes, Arduinos have an LED on them, but then you break out that LED, you learn to put it through a resistor, you learn it has to go to ground, you learn how to control it. This takes very simple concepts and builds on them. How do you use an external module that might work via SPI or I2C? Well, this project does that. And all the sound reactive side of it, if you're not ready for that, you can just take the code that they've used. I really enjoyed this project. I'm really glad that it's getting recognized. Congratulations for a third place. And this is from Moises Diaz. And again, if you are liking this, come to the page, read it, and head to their YouTube channel. This is going to be another YouTube channel that I'm hoping they continue working on. And it is criminally unsubscribed. I love saying that about YouTube channels, and this one absolutely is. It is now time to talk about our product of the week, and it's one that we talked about before on the show. It is this, the Zimablade. Now, mine has a hard drive attached to it, which is one of the many great uses for it. This is in the middle of a secret project where it's going to be linked with other Zimablades, and we'll be hearing more about that in the future. But as it stands right now, even just as it is, this is one of the best NAS devices I've ever had. I just set it up just randomly just to see how it would be, and it has been absolutely flawless without any issues whatsoever. I'm very tempted to keep one of these just as that. Anyway, I'm not talking about me talking about the Zimablade, we're talking about Robin talking about the Zimablade, because as always, he's back with another one of his fantastically informative product of the week videos. Now, I'm not going to spend too much time extolling the virtues of the Zimablade. I've done that on this show before, with the Zimaboard as well, another Icewell product very similar. But Robin, as always, can go into the details that maybe I miss sometimes. What I will say, as someone who is a bit of a noob when it comes to home lab stuff, is that having an x86 single board computer that you can just plug in and go, all this needs is the Ethernet port and the power port, and this is done. It is a fanless x86 computer with upgradable RAM in it. It's been really nice for me as someone who is in the learning stages, getting up there now, but still very much a noob. Casa OS is great if you don't want to use Docker yourself, because it's basically a wrapper for Docker. And you can, of course, put anything that's compatible with any other x86 server on it. This currently has Ubuntu server on it, with a few other random libraries and bits and pieces for setting up a NAS. And the beauty of it is like any other server. This is a single board computer, but it is an x86 one, which makes it compatible with Windows if you want to run Windows on it. And in fact, I have containerized Windows on the Zimablade, and the performance wasn't bad, actually. Now, as always, I highly recommend you go and check out the fantastic blog and video that Robin and the team have put together about the Zimablade. But for now, I'm standing on this side of the screen, which I think you know by this stage what that means. We are giving away the Zimablade as the prize of our Product of the Week giveaway that we do every time we have a new Product of the Week. And the way you enter it is incredibly simple. You just need to be a subscriber to the Electromaker YouTube channel. You need to leave a little comment saying what you would do if you won the Zimablade, and leave the hashtag Zimablade. All one word, no capitalization or anything like that. Not that that matters. But yes, that is how we run all of the competitions at Electromaker. And bear in mind that I just want to know what you're making with it, because I'm very interested in that kind of stuff. But the prize winners are always chosen at random, which is why we want the hashtag to be there. It's very easy to search everyone that has entered and make sure that no one is putting duplicate entries in or anything like that. And yes, we will be announcing the winner of the Zimablade contest on next week's show. And I'm really interested to see what people come up with as their ideas. And if you do come up with something inventive to do with an x86 single board server, please do put it up in the Project Hub, because I'd love to read about how you did it. We're going to close out this week's show talking about the analog to digital converters on the Raspberry Pi Pico, the ESP32, and the Arduino Uno Rev 3. Now, I became aware of this through the Adafruit blog, but I'm actually going to link the blog post itself in the description. This was on the Adafruit blog, but it really is just a wrapper heading to Dr. Monk's DIY Electronics blog. And just a quick shout out to Simon Monk right here. I haven't come across any of his work before now, but having just done a little bit diving into who he is and what he makes. He has a webpage called Simon Monk as well, and he's written various books about things like Arduino programming and programming. If it is something you're interested in finding out about, or want to get maybe a book for someone who is learning, who likes learning through books — I'm a big fan of coding books and things like that — you might want to check out Simon's other work. Anyway, before I get too off track, it's a very simple idea. There's an analog to digital converter on the chips that you find on various popular development boards, and this was just a quick test to see how reproducible the analog to digital conversions on them are in terms of readings. He tests an ESP32 board, he tests a Raspberry Pi Pico board, and he tests an Arduino Uno R3 board. And the idea here is that he's interested in seeing if, as it says, if there's any dead zones at each end of the analog input voltage range, how reproducible the readings are, and linearity through the range. I'm not going to tell you the results of this. I would like you to go and give Dr. Monk's blog some traffic. It's a very nice experiment, and using the output of a PSU, a power supply, and a resistor and a capacitor to make a very stable power supply for them to read. And there's the ESP32 readings here, the Pi Pico readings here, and the analog Uno readings here, and the test code that was used in order to test them. Now, the eagle-eyed among you may have already realized which of the three is better, and it's not the one that I expected it to be, but yeah, just something that caught my eye this week, and it's such a simple idea, and something that I don't necessarily think to check very often. The DAC on various things is something that I am very interested in. If there was a chip that had a really high-quality DAC on it that was as easy to use and as cheap as any of the ones you find on other development boards, there's obvious reasons I'd love that, because I like making music with my microcontrollers. But the ADC has never been that important to me, And so reading this was something that was kind of interesting, and it's given me a bit of consideration as to how I will actually grab the analog signals that I need for projects in the future, depending on what chip I will be using. And just before we finish, one little plug for us. If you do want to get slightly more accurate analog to digital conversions with your microcontroller, but you don't actually have the resolution that you need, you can get quad-channel DACs for quite cheap that have 16-bit resolution. We stock them in the Electromaker store. They work via I2S or SPI, and they're only $15. Again, we don't have much in the way of sponsorship. I mean, Koitech help us pay the people who win our Electromaker of the Month contests, but things bought in our shop is really the bulk of what supports the show, and will hopefully continue it going for a much, much longer time. One other quick plug for Simon, who wrote this article. I just noticed when I was looking, he has an advert for his newer book on the side of this blog post. Let's get back to it. If you click on this and you actually head to his author page, of course, you can buy the book, the Coding 21st Century's Most Valuable Skill book. I just had a quick look at his author page, and it turns out he also has books like, for example, Programming the Raspberry Pi Pico and a few other things, many of which are available on Kindle Unlimited, if that is something that you have. If you are part of Kindle Unlimited, you can read, for example, Programming the Pico for free. If you have a family account and a younger person in your family who you would like to teach, maybe Simon will be able to help you with that. So yes, I just wanted to give a quick plug to his author page before ending the show. That was the podcast for this week. Thank you so much for your continued support. Thank you to everyone who downloads this podcast and listens to it through their day, whether it's on their commute or when they're out running, which is when I tend to listen to most of my podcasts. And thank you to everyone who supports us financially through the Electromaker store. It really is our shop that keeps the lights on. We do have some partners, like, for example, Koitech are the ones that let us do Electromaker of the Month. They're the ones that give the cash prizes to our winners. But yeah, in terms of keeping the lights on for the Electromaker show, it really is just our store that does that. So thank you to all of you that are shopping there already. However, regardless of whether you do or do not, this podcast will be here for you, and I very much look forward to chatting to you again next week. I hope we have a safe, fun, and creative time. Bye-bye.